Hi everyone. So today we'll be taking a look at this question called number of islands. So in this question, the ones represent land and the zeros represent water. So, um, like a bunch of landmass surrounded by water will be an island. So in this case, if we have to find the number of islands, you can see that all these ones are connected. So these all these ones are connected. So there's only one island in this grid. Coming to this matrix in this grid, you can see that this is one bunch of ones together. There's this one lying here, and then there is these two ones together. So number of islands is 3 in this case. So to solve this question, we will be using DFS. So you might ask why will we use DFS? So it's kind of intuition. You build this over time, um, and we know that in DFS you traverse a graph. Um, you can imagine this as a graph. Like all these ones are nodes, and if they are adjacent, that means they are connected. So now we can like convert this problem into a DFS question. So how do I do this? Um, so basically, to calculate the number of islands, um, I will do whenever I get one, that means I got a land. So I will do DFS for um, all the connected nodes. So if you see here, I am iterating over the grid, and whenever I'm finding one, I'm increasing the answer, like that is the count of islands, and I'm calling DFS on that landmass. And what this DFS is doing is taking grid as input, and it is also taking the indices, the row index and column index as input, and R and C is like the size of the matrix. Like R is the row size, C is the column size. And I take this in the DFS function. And in DFS, what we are doing is like we want to traverse in like all the four direction. Like so we want to check like for a node, like this is a node for example, right? So we want to check, we want to go to go travel in all of its neighbors, right? So the neighbor of this one is this one, this one. The zero is water, so we don't have anything here, and this one. So what I'm doing here is I'm in DFS I'm traversing in all these directions, all the four directions, and whenever I go to a one, so whenever I start the DFS, I first set that index to 0. So this is so that we don't come back to this island again while calculating DFS. So this is just like a simpler way. We don't have to keep an adjacency matrix. We just use the same matrix and we turn that node to 0, right? So yeah, so we can take a example of like how this works. So for example, for this first grid, what happens is we start here. If grid equals to 1, yes, grid equals to 1. So we increase the answer to 1, and then we do DFS on this starting point. So it comes here. So what it will do is it will convert this 1 to 0, and then it will try to traverse in different directions. So if you see, so it will first try to traverse. So it will, what I'm doing here is I took this matrix which contains 1 0 minus 1 0 0 1 0 minus 1. These are like the four directions that we want to traverse. So what I'm doing is I am iterating over each of this. So this. So first I will iterate over this 1 0. So our next becomes so current direction is like uh, is this car direction is this the total thing, and car direction 0 is 1, and car direction 1 is 0. So I am adding it to whatever index we started, right? We started with 0 0. So car direction 0, so we add 0 to 1. So we just go here. So we just go here. That's what I'm doing in this. So I'm traveling in like all the four directions. um, so yeah, so we calculate r next, we calculate column next, we calculate the row next, we calculate the column next, and then we check like the row should, whatever the row value we calculated, that should fit inside the matrix, right? It shouldn't go outside the matrix, it shouldn't go outside the matrix. So that's what I calculated here. And I also need to calculate that, I also need to check that the next grid element that we visit is also on 1, because 0 is water, right? And we are only interested in the land mass, so we only go when we find a 1. So we call the um, DFS for the next element. So we converted this 1 to 0, and then we do DFS here. So here once it comes, it will do the same thing. It will convert this into 0 and will do DFS this. So here it will do the same. It will call DFS, but when it tries to come here, this is 0. So this thing will fail, right? So it cannot go here. So next thing it will check is, it will actually check here, but this one we already converted to 0, so it won't go here. So next thing it checks is this. So here we find a 1. So we call DFS this one. So similarly it goes, similarly DFS calls goes, and we convert all these zeros to, all these ones to zeros. So everything becomes 0. And we don't, here in this loop, we don't find any more ones. So the just first one, when we find, we do DFS and everything gets converted into zeros. So yeah, so that's how you get the output 1. Hope this makes sense. Yeah, thanks.